This video, we're going to talk about how to determine a hole in a rational function. So the graphs of some rational functions will contain holes, and that'll be a point at which the function is not defined. And the reason we have holes is because some values of x will make both the numerator and denominator equal to 0. And holes are also known as removable discontinuities. So look at this example here. This represents the graph of f of x equals x squared minus 4 over x plus 2. So if we look at this function in factored form, we can see that x plus 2 is a common factor in the numerator and denominator. So the value of x equals -2 will actually make both the numerator and denominator equal to 0. So that's why you can see the graph of this function has a hole right here where x is equal to -2. So how do you determine where the hole is going to be in a rational function? You're going to factor the numerator and denominator and look for the common factors. The x coordinate of the hole can be found by setting the common factor equal to 0 and solving for x. So then you can find the y coordinate by plugging this x value into the simplified function that exists after canceling the common factor, and then we're going to compare with the graph. So let's start off with this example. So let's determine the whole of f of x equals x squared plus x minus 12 over x minus 3. So the first thing we need to do is factor. Okay, so if we look at the numerator, we have x squared plus x minus 12. So this is going to factor into x plus 4 times x minus 3. So if you need to review factoring, make sure you go back and review the factoring videos that are posted. So I'm not going to get into too much detail on that here. So we have f of x now in factored form as x plus 4 times x minus 3. And then in the denominator, we have x minus 3. So notice here we have this common factor, right? The common factor we have in the numerator and denominator is x minus 3. So what I'm going to do is figure out the x coordinate of the whole by setting x minus 3 equal to 0. And when I solve for x, I get x equals 3. So now I'm going to cancel that common factor and write my simplified version of f of x. So that's going to be f of x equals x plus 4. So now what I'm going to do is plug in 3 to this simplified function. So I have f of 3 is equal to 3 plus 4, which is equal to 7. Okay, that's going to give me the y coordinate of the hole. So that means there is a hole in the graph of this function at 3, 7. So let's go to Desmos and see how you can identify the hole when looking at the graph. So I'm going to set up my fraction and then type in my rational expression. And so what I'm going to do, if you look at this graph, you don't see a hole. Okay, so that's what's a little strange about Desmos. What you actually have to do is you have to go find the point 37. So like I'm going to trace along my graph. See how that point is always going to be a solid circle that's all filled in. And then when I get to 3, notice how that circle will change. So I have to play with my cursor a little bit until I get to exactly 3, showing me that there's a hole at 3. You see how it says 3 undefined? But it, like I said, is really hard to see if you just look at the graph. You have to take your cursor and then trace very carefully until you see that closed circle that we had before change here into an open circle when we get to that point that's undefined. So now let's determine the whole of this function f of x. So we have x squared plus 5x minus 6 in our numerator. If we go ahead and factor that, we're going to get x plus 6 times x minus 1. In the denominator, we have x squared minus x. If we factor that, that has a GCF, so that's going to be x times x minus 1. So if we write f of x in factored form, we have x plus 6 times x minus 1 over x times x minus 1. So if we look at this expression now, you can see that the common factor in the numerator and denominator is going to be that x minus 1. So what I'm going to do is I'm going to start off by setting that x minus 1 equal to 0 and then solving for x. That's going to give me x equals 1. So that's the x coordinate of the whole. So I'm going to cancel this common factor and write the simplified function, which is f of x equals x plus 6 over x. And then I'm going to plug in f of 1. So when I have f of 1, I have 1 plus 6 over 1. So that's equal to 7 over 1, which is 7. Okay, so the hole in this graph is going to be located at 1, 7. So now let's go to Desmos and see if we can find that on our graph. I'm going to type in the original function, x squared plus 5x minus 6, and then that's over x squared minus x. And the whole is at 1, 7, so I'm going to try to find 1 on my graph here. Okay, so it's going to be here. You see when I cross that point, my cursor changes. It becomes an open circle. And you can see that it says 1 undefined, okay, because that's the location of the hole on this graph. So now you can go ahead and pause the video and try determining the hole of this function. So here, when we factor the numerator, we're going to get a GCF. So we have 2 times x squared plus 2x minus 8. So that's going to factor to 2 times x plus 4 times x minus 2. When we factor the denominator, that's the difference of squares. So we have x plus 2 times x minus 2. You can see here that the common factor we have in the numerator and denominator is x minus 2, and we set that equal to 0, we get x equals 2. Okay, and then when we write the simplified function, we have 2 times x plus 4 over x plus 2, and we plug in that value of 2. So that's going to simplify to 3. So the hole is going to be located at 2, 3. So if we go to the graph of this function, and if we go to 2, you can see here when I move that point to 2, it's going to change from a filled in circle to an open circle. And notice that it says undefined because that's the location of the hole on this graph. So remember, holes of rational functions exist at values of x that make both the numerator and denominator equal to 0.